Okay, guys, welcome to your notes about function operations and composition of functions. You can follow along with me on pages 5 and 6 in your notes packet. Okay, my voice is a little bit raspy today, so please just bear with me and I'll try to make sure that everything is as clear as possible. Okay, so let's start with some vocabulary. So the first thing that we mention is the word a composite function. Okay, and I've kind of highlighted that a little bit for you. And it's a combination of two functions where the output from the first function becomes the input for the second function. Now, this is a little bit of like a fancy definition for it, okay? But what it means is you take the results from the first function and you plug them into the second function. And we'll show you some examples of that a little bit later on in the notes packet. So I'll refer back to this at that point, okay? Below that, let's look at some of this notation. Guys, this is really important because there is some confusion with this that I see. Okay, so if you look with the addition, subtraction, multiplication, and division, you'll see the left side says f plus g parentheses x, right? Notice that that is f of x plus g of x. Okay, a lot of times people want to tell me that's f plus g times x. Okay, so the key thing I want to get at is, guys, when you see this x at the end in parentheses, that is not multiplying x. Okay, if you see a number there, so if it was f plus g of -3, that is not multiplying. Okay, so I'm going to make a little note here. This is not multiplying, because that seems to be something that you guys really commonly want to think that, hey, I see the two things touching, it's in parentheses, it must be multiplication. All right. But other than that, guys, you can see how the notation looks. F plus g of x written two different ways. One is with the x at the end in the parentheses. The other one is each function showing that x with it. Let's look at some examples of this and put it into action. Okay, just below that box we looked at on page 5, you'll see 4 examples written for you, and this is number 1 of those examples. Okay, it says f plus g of x. Once again, not times x, it is f of x plus g of x, and I'm going to rewrite that down below. This is the same as f of x plus g of x. Okay, and off to the side here, I listed out the 3 functions in blue. Those are at the top in that bold text. Okay, so what do I mean by f plus g? Okay, that means I need to take the two functions f of x and g of x and add them together. So let's write it out. Okay, and I'm going to write them out vertically because I find that a little bit simpler. So I'm going to start with f of x. So here we go. F of x is 2x squared plus 3x minus 5. And g of x is going to be x squared minus 9x plus 20. And what am I going to do with these two? I'm going to add them together. Okay, so here we go. Let's add f of x plus g of x. And I lined these up at the beginning because I really want it easy to add. So if I just kind of combine my like terms, so 2x squared plus x squared, there's 1, 2, 3 x squareds. Okay. 3x plus negative 9x is going to be minus 6x. And negative 5 plus 20 is positive 15. Okay. So this right here, guys, is your f of x plus g of x, what the result is. Okay. Now, people use some slightly different methods to organize themselves, but overall, you should end up with the same result. You should have combined your like terms and gotten to this final result. Now, when we look at our next example, you're going to see there's no x in that one. So still in that same section that we were on, we're looking at f minus g of -3 this time. Okay. So once again, let's translate that into notation that seems a little bit more straightforward to us. So this is going to be f of -3 minus g of -3. Now, my suggestion, once we've broken this down, Let's calculate what each of these are and then subtract it, okay? Trying to do the subtraction and then plugging our numbers in is going to make it a little bit more difficult compared to if we evaluate by plugging in numbers and then subtract, okay? So let's start with f of negative 3, okay? So once again, here's my f of x function. That was listed in the bold text. So I'm going to plug in negative 3 for that. So here we go. F of negative 3 is going to be 2, and instead of x, I'm putting negative 3. Notice I put parentheses, guys. This is really important, especially when we work with negatives. Put the parentheses in there, and it will keep you from making a lot of mistakes, okay? Because otherwise, a lot of you guys will forget when you square, negatives cancel or they don't cancel. And if you're using your calculator, you want to always write things the way that you want to put them in. Okay, you never want to miss something because you're like, oh, I knew what to do, but I wrote the question wrong. Okay, so now let's calculate this out. So here we go. 2 times negative 3 squared. So that's 9 times 2 is 18 plus negative 9 minus 5. And so overall, I should get this result as being positive 4 as my final result. So f of negative 3 is 4. So now let's take our G and do the same thing, the second bit here. So I'm going to do this piece in white right here. So I'll put a little arrow. Here we go. G of negative 3. And again, what am I doing? I'm going to take the G function up here and plug in negative 3 to that. So here we go. Negative 3 squared minus 9 times negative 3 plus 20. Okay. And let's calculate this out. So we got 9 minus, or sorry, plus 27 now, because the two negatives cancel out, plus 20. And I believe we get 56. And that's going to be my value for G of negative 3. Okay. So now that I've got these two numbers, what am I supposed to do with this, right? Those are not my answer yet. Well, the operation asked us to subtract these. So what I'm going to do is let's subtract the two numbers that we just got. So here we go. Let's do f of negative 3 minus g of negative 3. And we already know these numbers. So 4 minus 56 is equal to negative 52. And that's going to be my answer. So f of negative 3 minus g of negative 3 is equal to negative 52. Okay, guys, let's look at the box that's at the bottom of page 5. We're going to talk about a piecewise function, which is a function that has different rules for different parts of its domain. And this is kind of a real world thing because a lot of times, guys, our math equations are a little bit too simple for the situation, right? Sometimes the rules differ based on where you are, okay? One example I like to give about piecewise functions is based on what category your x belongs to, you're going to follow a certain rule, right? So imagine it's the first day of school and all the students are coming in. So if I was guiding traffic, I might be telling my students, hey guys, if you're a freshman, please go to the library. If you are a sophomore, please go to the big gym. If you're a junior, go to the small gym. And if you're a senior, please go to the auditorium, right? So based on what category my students are in, right? If you're a freshman, you go to the library, so on and so forth. I would know what rule to follow. Okay. In the same sense, a piecewise function has two parts to it. It's going to have the function's behavior and what section of the domain it belongs to, what rule it needs to fit into to use that. Okay. So let's start by labeling our three different lines on this function. And I'm just going to call them A, B, and C. Okay, so we're going to figure out, hey, should I use A? Should I use B? Or should we use C? Okay, and I labeled them in different colors. So let's just look at part 1, the problem 1, where it says f of negative 2. And my question to you guys is, which category does this negative 2 belong in over here? Okay, so the first question, let's see. Is negative 2 less than or equal to negative 3? No. Okay, so I'm going to go ahead and say no to this. This is not correct. Let's look at the next category. Is -2 in between -3 and 1? Okay, and that's a little bit messy. I'm going to rewrite this piece. Right. Is this true? Yes, this is true. Okay, so it looks like we belong to category B. Let's go ahead and just check the third one just in case. Okay, so here we go. Is -2 greater than or equal to 1? Okay, and you're going to go ahead and say, no, that's not true either. So we obviously belong to category B. So what we're going to do is we're going to look at function B, which says -2x, and that's what I'm going to use. I don't care about either A or C anymore. I'm only going to use the rule for that one. So let's plug in -2 into there. So that is going to be -2 times -2, and I should get that this is equal to 4. So that's how you evaluate a piecewise function. Okay, let's do one more example. So if we look at the second problem in this section, the one that says number 2, f of 7, we first need to figure out which category does this belong to, right? So I'm going to look at this 7, and I'm going to ask myself, does it belong to group A, group B, or group C? Okay, so we can compare based on this section right here. Does 7 belong to which of those categories? Well, I'm going to go ahead and tell you 7 is greater than or equal to 1, which means this is going to be in function category C, right? That third function. So what math should I do for this function? We're going to do x squared minus 3. So here we go. We're going to take 7 and plug it in for that x. Minus 3. 7 squared is 49. Minus 3 is 46. And f of 7 is equal to 46. Okay, so just make sure you check, hey, which section does this belong to? And then boom, you'll be able to plug in the number in the right function rule. Okay, guys, we're now at the top of page 6, and we are looking at some examples of function composition. Okay, so that was the thing that we mentioned at the very beginning at the top of page 5. So function composition is kind of when you plug one function into the other, right? You use what you got from the first one to solve for what the total for the second one is going to be. Okay, so let's look at some examples of this. So the first one I see is number 1, f of g of 3. Okay, and that's exactly how we read it. F of g of 3, right? From the outside inward. And the best way to solve these, in my opinion, is start from the inside right here, g of 3. So how can I find g of 3? Well, they've told us what g of x is up here. And all I'm going to do is I'm going to start by taking that function and plugging in my 3. So 3 squared minus 9 times 3 plus 20. And we can solve this down. 9 minus 27 plus 20. And we should get this as 2. Okay, so I've got my g of 3 is equal to 2, which means now I can take this number 2 and plug it in to the rest of my function, because I already know that g of 3 is 2. So let's replace this g of 3. So now I've got f of 2. And this 2 is, of course, coming from what we just solved. Okay, right there. So how do I find f of 2, guys? Simple. Let's do the same thing again, right? We're going to take that 2, and this time we're going to plug it in for that f that we know. So here we go. 2 times 2 squared plus 3 times 2 minus 5. Again, guys, notice these parentheses. If you put parentheses around this, you will never make a mistake, okay? You can't go wrong with having too many parentheses. So here we go. We're going to get 8 plus 6 minus 5, and we should get our final result to be 9. So overall, this whole thing that we were trying to calculate, f of g of 3 is going to be equal to 9. Okay, and that, guys, is how we do function composition. All right, Let's try one more of these real quick. Okay, guys, so let's look at number 2 as our next example. Once again, we're going to start from the inside. Okay, so f of -4. So here's my f function, f of x, and let's plug in -4 into there. Okay, so this is going to be f of -4 equals 2 -4 squared plus 3 times -4 minus 5. Let's simplify and solve this down. 16 times 2 is 32 minus 12 minus 5. And we should get this as 15. Okay, so f of -4. So now that we've got that inside bit, let's set up the outside bit, h of, and we're going to plug in this 15 that we got. Okay, so over here we've got that h function, and we're going to solve that using 15. So here we go. We've got 15 minus 7. And I'll put parentheses just to show that I'm plugging that in. So what's 15 minus 7? Just 8. And so we can overall say that, hey, h of f of -4 was equal to 8. Okay, so start from the inside, solve that bit, plug that number into the next bit, and so on. Okay, guys, one last example, a little bit of a challenge for you guys. Okay, so at the bottom, you can see this time we have two piecewise functions, and we're going to see how we would evaluate those. Okay, so I chose number 3 as our example. This one has some interesting notation. You see this open circle? The first big thing I want to note about this, guys, the open circle is not multiplication. Okay, let's just make a note right now. Not multiplication. Okay, that is the same thing that we just did, composition, where we plug one into the other. Okay, so this actually reads as f of g of 1. Okay, so we are taking g of 1 and plugging it in to this equation. So let's make sure that we do that right. Okay, so let's start with this. Wait a minute. Let's start with that inside piece like we did before. So what is g of 1? Well, first of all, we're going to have to figure out which rule to use here. So x is greater than 2. We would say x is less than 2. So is 1 more or less than 2? I'm hoping that you guys got that it's less than 2 here. Okay, so 1 being less than 2 means my function just says 5. Whoa. No x, nowhere to plug it in, right? So the value is actually just 5. All you have to do is put 5. We don't have to do any math there. Okay, so awesome. Now we've got g of 1 done. Let's take a look at what if I plug that in again for my f. So now that we've solved g of 1, we know that this is f of 5. Let's figure out where we should plug that in. So here we go. Is 5 greater than 3 or less than 3? Hopefully you guys all said that it is more than 3, so we're going to use this first row, right? So this is actually going to be equal to 2 times 5. And 2 times 5, you guys already know that's 10. So f of g of 1 is 10. Okay, so this problem involves combining what we just learned about piecewise functions and composition. Make sure you check, guys, which rules should you follow. Okay, you can only follow one of the rules. Whichever one you fit into, use that f of x. Don't use the other one at all. Okay, awesome. Hope you guys find this video helpful. Make sure you refer back to this when you guys work on your homework and look at the examples that we've done. Okay, have a great day.